All right, so today we're going to be looking at lesson 15.3, dealing with parallelograms. We're continuing our discussion of different types of quadrilaterals. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So it has two pairs of parallel sides. You can use this symbol here instead of writing out the word parallelogram. So they give us a parallelogram, KATY, and they ask which angles are consecutive to angle K. So in lesson 15.1, we talked about consecutive angles. Those are ones that are right next to each other. From angle K, angle Y is consecutive, and angle A is consecutive. They are adjacent to, they are right next to angle K. Then, using information about parallel lines, they want us to complete a theorem. Consecutive angles of a parallelogram are what? So if you look, these lines are parallel. This angle and this angle are same side interior angles, and those are supplementary. Likewise, angle K and A are same side interior angles, and so they are also supplementary. So for all parallelograms, your consecutive angles are supplementary. Now we're going to look at number 2. They want you to cut out 3 index cards and draw 3 different parallelograms and cut them out and draw a diagonal and cut along the diagonal to create 2 triangles. And they're hoping that you notice something. So if you want to do that, you can. I'm going to just draw a parallelogram here. And then if I draw the diagonal, it creates 2 triangles. And what they're hoping that you notice, this triangle and this triangle are congruent. So what do I notice about each pair of triangles? Each pair of triangles are congruent. And that's going to be the case for every parallelogram. Your diagonal is going to cut it into congruent triangles. So now we're going to look here. Based on that information, each diagonal of a parallelogram divides that parallelogram into 2 congruent triangles. So that's another theorem that we have about parallelograms. And so from there, we have triangle DIAG, and they want us to complete this statement. Opposite sides of a parallelogram are, so opposite sides are this DI and this GA, as well as DG and IA, and they are going to be congruent. Your opposite angles of a parallelogram, so that's GI and D and A, they are going to be also congruent. And so now what we're going to do in part C and D is actually prove those 2 theorems. So, first thing we need to do is to notice that we have 2 triangles. We have triangle DGI and triangle IAG. And in those triangles, our sides DI and GA are parallel. And our sides DG and IA are parallel by the definition of a parallelogram. Since those sides are parallel, we have angle pairs that are congruent. I know that this angle is congruent to that angle, and I know this angle is congruent to this angle. And the reason is because of alternate interior angles. So I can say angle DIG is congruent to angle IGA, and angle DGI is congruent to angle GIA, and the reasoning is by alternate interior angles. I also know that GI is congruent to IG by the reflexive property, because they share that side. And now I have my two triangles that are congruent. So I can say triangle DGI is congruent to triangle AIG, and the reasoning is angle side angle, because that's what I have marked in my triangles. And then if my triangles are congruent, I know that all of the corresponding parts are congruent, which means that my corresponding sides, DG and AI and DI and AG must be congruent. And the reasoning is CPCTC. So CPCTC is corresponding parts of congruent triangles are congruent. Once you know your triangles are congruent, all of the parts have to be congruent. And so that means your corresponding sides have to be congruent. So that's proving that your opposite sides of your parallelogram are congruent. Now looking at the next one, we want to prove that opposite angles are congruent. So continuing from part C, we know our triangles are congruent, so I can say that angle D and angle A are congruent. And the reasoning is by CPCTC. I know that my corresponding angles have to be congruent. Now we need to draw the other diagonal. So we're going to draw that diagonal from D to A. And we're going to do a very similar proof, but using the other diagonal. So we know that this angle and this angle are congruent, and we know this angle and this angle are congruent. And the reasoning is, again, alternate interior angles. So in our triangles, we have our sides DI parallel to GA and DG parallel to IA by definition of a parallelogram. And so then we can say that our angle pairs are congruent. So angle IDA is congruent to angle GAD, and angle GDA is congruent to angle IAD by alternate interior angles. So then we know that the side that they share has to be congruent. So we can say AD is congruent to DA by the reflexive property. And then we can say that our triangles are congruent. So triangle DAG is congruent to triangle ADI by angle side angle. And then if our triangles are congruent, the corresponding parts are going to be congruent, which means angle G has to be congruent to angle I by CPCTC. And so that proves that the other pair of opposite angles would be congruent, proving your opposite angles are congruent for your parallelograms. So now we're going to look at the next page. Explain why the theorems that we just proved are considered corollaries to the theorem above it. So a corollary is a statement that results directly from a theorem. It's kind of like a subset of a theorem. Based on one theorem, we know this other more specific information. So let's go back to the previous page. They're talking about how do we know these two theorems follow from this one. So how are they related? Well, this first theorem tells you that you have two congruent triangles that are in your parallelogram. This next part is talking about the parts of those triangles being congruent. So you could think of it as CPCTC. We know we have congruent triangles, so all of the parts are congruent. Your opposite sides and opposite angles are corresponding. So they're corresponding parts of the congruent triangles that were discussed in number 2. So the theorems in number 4, I guess it was number 3 that was talked about. The theorems in number 4 are dealing with your opposite sides and opposite angles, and they're corresponding to those parts of your congruent triangles from the part 3. So that's why they are related. So now we're going to look at number 6. They give us a parallelogram, LUCK, and then we want to answer A, B, and C. So they start off by a triangle, KCL, and they want us to figure out what it's congruent to. So it's very important that you pay attention to which parts are corresponding. So K corresponds to U. So K comes first, U is going to come first. Now, the next part is looking at C. These lines are parallel, and this is the transversal. So this angle, C, is corresponding to this angle, L. So whenever they say C here, the next one is going to be L. Likewise, these are parallel with this transversal, and L corresponds to C. And so that is the triangle that ends up being congruent to triangle KCL. Another way, you could look at it as actually rotating it. So I'm going to rotate it. And if you see, K matches up with U, C matches up with L, and L matches up with C. So just because you see CL here doesn't mean that you're going to have CL there. It is possible that the letters end up not corresponding to each other from various triangles. So now we're going to look at B. They give you angles. Angle KCU and angle K. Well, those are consecutive angles in your parallelogram. So what that means is that the measure of angle KCU and the measure of angle K are supplementary, which means they equal 180. So we can set up the equation 10x minus 15 plus 6x plus 3 equals 180. And from there you solve for x. So combined like terms, 16x minus 12 equals 180. Add the 12 to both sides to make 16x equal 192. And then divide by 16 to make x equal 12. And that's all it asks for, solve for x. Part C is asked about the sides. So it tells you you have a parallelogram. So you know these sides are congruent and you know these sides are congruent. So they tell you KL, they tell you UC. So one equation that I can create there is that 2x plus y equals 14. They also tell you UL is 7 and KC is 5x minus 4. So the other equation that you can set up is that 5y minus 4x equals 7. From here, you could do substitution or elimination. I'm going to do substitution, but you're welcome to do elimination if you prefer that. So y is going to equal 14 minus 2x because I need to subtract the 2x and move it to the right side of the equation. Then I can take this y value and replace the y in the other equation. So instead of saying 5y, I can say 5 times 14 minus 2x because that's what y equals. You can just replace them. And then I have minus 4x equals 7. So then you distribute to get 70 minus 10x minus 14x equals 7. Combine like terms to get 70 minus 14x equals 7. I am going to subtract 70 to make negative 63, and then divide by negative 14 to produce x equals 4.5. From there, we need to come back up here and plug that in to solve for y. 2 times 4.5 is 9, so 14 minus 9 tells me that y must equal 5. So now we're going to look at another theorem. The diagonals of a parallelogram bisect each other. So that means they cut each other in half. It wants us to start off by writing that theorem as an if-then statement. So, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So that's putting it as if then. If it's a parallelogram, the diagonals bisect each other. Part B wants us to draw a figure. So I'm going to draw a parallelogram. And I'm going to label A, B, C, D. And I'm going to draw the diagonals and label the intersection as M. And then we are given that we have a parallelogram. So we're given parallelogram A, B, C, D. And we are going to prove that the diagonals bisect each other. So in my figure, my diagonals are AC and BD. And so now part C asks you to write a 2-column proof for that theorem. So, start off by setting it up. Statements and reasons. You always start with your given, and so our given information is that we have a parallelogram. And we named it ABCD. So parallelogram ABCD. Since we have a parallelogram, we know that our sides AB and CD are parallel because that's part of it being a parallelogram, that the opposite sides are parallel. So the reasoning that we would put there, definition of parallelogram. If those sides are parallel, we have angle pairs that are congruent. We know this angle and this angle are congruent. We also know this angle and this angle are congruent. And so we can say angle ABD is congruent to angle CDB. And angle AC is congruent to angle DCA. And the reasoning is because they are alternate interior angles. So what I am trying to get to prove is that this triangle and this triangle are congruent. That's what I'm working towards. And the reason that I know they are congruent, there's one more piece of information I need. I have two angles. I need to show that the sides here are congruent. And so I know side AB is congruent to side CD. And the reasoning is because it's a parallelogram. That's part of the definition of a parallelogram. So now I have my two triangles are congruent. And the reasoning that triangle AMD is congruent to triangle CMD is by angle, side, angle. So then, once I know my triangles are congruent, I know all of the parts are congruent, which means that I can say this side is congruent to that side, and that side is congruent to that side. So I can say AM is congruent to CM, and BM is congruent to DM. And the reason is CPCTC. Corresponding parts of my congruent triangles are congruent. From there, if these four are each congruent, that means that my diagonals have to bisect each other because it cuts them both in half. So I can say that AC and BD bisect each other. And the reasoning that I can say that is the definition of bisect. Definition of a bisector, definition of bisects. We know that the two parts were both cut in half, and that's what a bisector does. So now, let's look at the next page. Why are trapezoids and kites not parallelograms? Well, we talked about trapezoids in lesson 15-2, and we knew that they had one pair of parallel sides. We talked about kites in lesson 15-1, and we were told that they do not have any pairs of parallel sides. Today we're looking at parallelograms, and they have two pairs of parallel sides. So trapezoids and kites are not parallelograms. They do not have two pairs of parallel sides. There are probably other properties that they don't have that a parallelogram does have, but that's the most basic one. So looking at number 9, one angle of a parallelogram, they tell you, is 68. The opposite angle of that parallelogram is going to be congruent because opposite angles are congruent. So one of the angles is going to be 68. Then we need to find the other two. We know consecutive angles are supplementary. So if this angle at the bottom left is 68, this angle at the top left is supplementary, so it has to be 112. And then if it is 112, the angle opposite to it is also 112. So if one angle is 68, another angle is 68, one angle is 112, and another angle is 112. Then looking at number 10, the lengths of two sides of a parallelogram are 12 and 18 inches. So if I have, we can use the same parallelogram. One side is 12, one side is 18. The other two also have to be 12 and 18 because I know that my opposite sides are congruent. So they have to be 12 and 18. So now let's look at 11. They tell me that AC and BD are diagonals in my parallelogram. we know that the diagonals bisect each other. So that means that these parts are congruent and that these parts are congruent. So each of these expressions is referring to your diagonal parts. They don't have a little degree symbol, so that's how we know they are not angles. So I can say 3x minus 13 equals x plus 1. And then if I subtract x, 2x minus 13 equals 1. You can add 13 to make it 2x equals 14. And then x equals 7. Then plug that in. 7 plus 1 is 8, so DE would be 8. Over here, 3 times 7 minus 13 would also give you 8, and they're supposed to be the same. They should both be 8. For the other part, 2y equals y plus 5, so subtract y, and you get that y equals 5. Then I can plug that in here. 2 times 5 is 10, so AE is 10. And then EC, 5 plus 5 is also 10. And they should be, because they are bisected. They should be the same length. Looking at number 12. They give us sides and angles. These sides are opposite, so they are congruent. So we can say 6a equals 4a plus 10. So subtract 4a, and I have 2a equals 10. Divide by 2, a equals 5. So then that means that this side is 30, and that means this side is 30. So WZ is 30, and XY is 30. Looking at the angles, these are consecutive angles, which means that they are supplementary. So I can say 2B plus B plus 15 equals 180. So 3B plus 15 equals 180. If you subtract 15, you get 3B equals 165. And then divide by 3, 3B, or B would be 55. Then you plug that in to find your angles. 2 times 55 means that angle Y is going to be 110. That also means angle W is 110 because it's opposite angle Y, and those are supposed to be congruent. Angle X is supplementary to angle Y, so angle X should be 70. And if you plug 55 in, 55 plus 15 is 70 degrees. And then Z is opposite, so it should be congruent to angle X. So hopefully that helps you a little bit with understanding your parallelograms. I do want to go over some of the properties again of your parallelograms to make sure you've got all of those in one spot. So these are properties of a parallelogram. There are 6 of them. So if you want to see, if you can pause the video and find all 6 of them by yourself, go for it. One of them, opposite sides are parallel. Another one, consecutive angles. Are supplementary. Another one, diagonal divides the parallelogram. Into 2 congruent triangles. Another one, opposite sides are congruent. Another one, opposite angles are congruent. And then the last one is that the diagonals bisect each other. So those are your 6 properties of parallelograms that we looked at today. just so that you have them all together.